Hello guys, today we are going to talk about lubrication and sliding bearing. So what is a bearing? It is applied to a machine or structure, refers to a conducting surface through which a load is transmitted. For the lubricants, there are any interposed substance that minimize friction. They are usually liquid, but they also can be solid, such as graphite or pressurized air. For modern oil lubricants, they usually contain one or more additives. Pour point depressants. They cause the oil to flow at lower temperature. The viscosity index improver. It has less variation of viscosity with temperature. Deformants, resisting foaming when agitated in high-speed machinery. And the oxidation inhibitors resist oxidation at high temperature. Corrosion inhibitors prevent corrosion of metal surfaces. Detergent and dispersants minimize the formation of engine deposits. Anti-wear additives reduce friction and wear. Greases are second liquid lubricants. They are used when the lubricant needs to stay in position. It can prevent harmful substance from entering between bearing surface, and then also have a cooling and cleaning function. And for introduction to sliding bearings require direct sliding of load-carrying members on its board. They don't have balls or rollers interposed between the sliding surface. Usually, there are thin shells that can be easily replaced. It can be split or can be made as one-piece cylindrical shell, known as bushing. So this is a journal or sleeve bearing. It is cylindrical and supports radial loads. And this one is thrust bearing. It is flat and support loads in the direction of the shaft axis. For the types of lubrication, it is usually classified according to the degree it separates the sliding surfaces. The first one, hydrodynamic lubrication. The surfaces are completely separated from lubricant film, surface where this doesn't occur. Typical film thicknesses at the thinnest point is 0.008 to 0.02 mm. Friction originates only within the lubricant film. Typical values for the coefficient of friction are 0.002 to 0.01. The next one is mixed film lubrication. The surface peaks are intermittently in contact. With proper design, surface wear can be mild. Coefficient of friction range from 0.004 to 0.01. The third one is boundary lubrication. In boundary lubrication, surface contact is continuous and extensive, but the lubricant reduces friction and wear. Typical values of F are 0.05 to 0.2. Besides those three basic cases, there's one special one called hydrostatic lubrication. In this case, the surface is completely separated with a high pressure fluid, such as air, water, or oil. The figure ABC on the top refers to hydrodynamic mixed film and boundary lubrication, and the two figure on the bottom is the difference between the hydrodynamic lubrication and hydrostatic lubrication. In hydrodynamic lubrication, it is provided by atmospheric pressure difference, and some eccentricity is presented, different from hydrodynamic lubrication. Hydrostatic lubrication is provided by the bump, and there's no eccentricity. Next is basic concepts of hydrodynamic lubrication. From figure 1, when the loaded journal bearing at rest, the bearing clearance is filled with oil, but the load has squeezed out the oil film at the bottom. From the figure B, slow clockwise rotation of shaft will cause it to roll to the right, and continuous slow rotation will cause the shaft to stay in this position, and now the boundary lubrication happened. From figure C, when the shaft rotating speed is increased, pressure is built, and the shaft floats. Under suitable condition, the minimum field thickness is reached. This is hydrodynamic lubrication. There are three basic parameters influence the type of lubrication and the coefficient of friction. The first one is viscosity. The higher the viscosity, the lower the rotating speed needed to float the journal. The higher viscosity produces more bearing friction. The second one is rotating speed. The higher the rotating speed, the lower the viscosity needed to float the journal. The higher rotating speed produces more bearing friction. The third one is bearing unit load, defined as the load W divided by the bearing project area. The smaller the bearing unit load, the lower the N and the viscosity needed to float. Reducing the bearing load will increase the bearing coefficient of friction. There are three elements to achieve hydrodynamic lubrication. The first one is relative motion of the surface. The second one is wedging action, which is shaft eccentricity, which we talked before. It is the main difference between the hydrodynamic lubrication and the hydrostatic lubrication. In hydrodynamic lubrication, the shaft will not stay in the middle, but in hydrostatic one, the shaft will stay in the middle. And the third one is the presence of stable fluid. The last topic is an example for lubrication in engine. When engine crankshaft being cranked and turns slowly, the boundary lubrication occurs, and then the loads are small because there's no combustion loads. When the engine starts, combustion adds greatly to the bearing loads, but the rotating speed increases sufficiently to establish hydrodynamic lubrication. Peak combustion loads are of momentary duration. The inertia and transient squeeze film effects prevent the oil from being squeezed. And this is the end of introduction to slide bearing and lubrication. Thanks for watching.